Chapter 10, Respiratory System, Screencast 1. Now, another name that you'll hear for this system is pulmonary system. So both of those terms are actually interchangeable. So the first thing that we have to look at is some of the introductory terminology that is used throughout this chapter. Breathing, now that's nothing more than the mechanical movement of moving air in and out of the lungs. You'll hear it termed as ventilation. External respiration, that's gas exchange between air and blood in the lungs. And notice there's something outside going on, the air. Then we have internal respiration, and that's actually gas exchange between blood and tissues. And notice internal respiration is completely, totally enclosed within the body. Then we have cellular respiration. We talked about this back in chapter 3 on how cells get energy, and that's really what this process is. So the use of oxygen to produce ATP, and all of the carbon dioxide that we actually exhale as a metabolic waste is a result of cellular respiration. Now, other things that we use the respiratory system for, especially, is going to be vocalization and, once again, oral communication. Now, from an anatomical standpoint, the respiratory system is actually divided into two general areas, the upper and lower respiratory tract. The upper respiratory tract basically consists of the nose, nasal passages, sinuses, and the pharynx. And the lower respiratory tract is made up of the larynx, trachea, bronchi and bronchioles, lungs, and alveoli. Now, you may see another term as far as conducting zone and respiratory zone. And conducting just implies air is moving through. That's it. There's no gas exchange at all. And then if we look at the other area where exchange is actually taking place with the structures that we are covering, that's actually limited to the alveoli. So that's actually where gas exchange is actually taking place. Here we can see the general breakdown of the structures, and once again we'll probably spend more time going into a little bit more detail, specifically as we address each one of these areas. But here we can kind of see there's the cutoff, okay? So basically these are those nasal passages, and keep in mind most of us are nose breathers, okay? And so we see the nasal cavity. This is where actually air is conditioned. It's warmed, it's filtered, and it's humidified. So very important function there. And then we have the pharynx, okay? And that pretty much is about it for the upper respiratory tract. Here, there is the larynx, commonly known as the voice box, the trachea. And then we basically look into the lungs deeper. And alveoli, once again, there's that that respiratory zone where gas exchange is actually taking place. Now, the major role, as noted already, of the upper respiratory tract is actually to filter, warm, and humidify the air. Think of it being conditioned. So that's a term that you'll see fairly regularly. Now, when we're looking at the nose and pharynx, we also need to keep in mind that as far as the pharynx goes, that is shared with the digestive system. From our standpoint, we're going to look at it pretty much entirely as a conducting zone. So that passageway for ventilation. Okay? We're going to have receptors within the nose that enable us to smell. We talked about that previously in chapter 12. We're going to filter larger foreign materials that are being inhaled. There may be some microorganisms, and they are actually going to be trapped into mucus. We've already addressed the role of moistening and warming the air that is coming into our body. And that's especially important. Kind of imagine those really cold winter days. The first thing you do, you go outside, you take that big, deep blast of cold air, and it hurts. So slow down the breathing and allow the air to actually get conditioned. So that's important. And then once again, resonating chambers that allow us to speak and use our voices. Here you can see the sinuses. So those are basically the structures There's cavities within the bone, so that's really what we're looking at. As far as a sinus, we're going to be looking at the internal component of the nasal cavity. These actually, when air moves in, creates a turbulent flow, so the air will spend longer time. There's the opening of the auditory tube. We saw the other end when we were looking at the structures of the ear. And here's the pharynx. And so this area of the pharynx is also going to be shared with the digestive system. And when we move on to some other structures, we'll see that the epiglottis, this actually will flip over, excuse me, the trachea when we're eating, so that food moves down the esophagus and not into the larynx, okay? The wrong pipe, so to speak, okay? Now, the larynx, as I indicated at the superior end, is the epiglottis, and that is actually a very flexible flap of connective tissue. And what it does, once again, part of the swallowing reflex causes it to flip over the opening of the larynx, the glottis, and now food will move into the esophagus and not into the larynx. Within the larynx, we're also going to see the vocal cords. They play an important role in the production of sound. And because of the larynx and the cartilages there, it actually keeps the airway open. Now, the trachea, that's the next piece. Okay, so we're now looking at the beginning of the lower respiratory tract, and that is actually moving air to and from the lungs. Another term that you'll hear for the trachea is windpipe. Now, what's characteristic, it's kept open by these C-shaped rings of cartilage, and that's going to be important, right? Now, also, it's lined with mucus-secreted ciliated epithelium, and that actually traps substances, and it moves them up and out. And one of the things that we do is we cough that up. So part of the coughing reflex is related to getting rid of that mucus that contains these microorganisms and other particles that were trapped while we were breathing. So here we can actually see the lungs. So the original first tubes are bronchus, and then we're going to get into smaller tubes, bronchioles, and then actually into the alveoli where gas exchange is taking place. So here's a complete view of the lower respiratory tract. Here, looking down, okay? And so this is basically a posterior side, okay? Or anterior, excuse me. And what we're looking at here is we're looking down, and that space is the glottis. There's your true vocal folds, and off to the side are these false cords or vestibular folds that we can kind of see here. And so we can really see the trachea, okay, and the tracheal cartilages overall. And this is a posterior view because this large piece here is the thyroid cartilage. These are the specific cartilages that we see within the trachea. Okay, and you can see the epithelial tissue once again, ciliated tissue, so it kind of traps things. It also has goblet cells which are producing mucus. Now, the bronchi, so the trachea branches into two airways, the right and the left bronchi. Bronchus is singular, and once again, we're going to see that ciliated epithelial tissue, smooth muscle, and cartilage. Then we get to bronchioles. Now, as we're starting to get deeper into the respiratory tree, one of the things that we're going to see, we're going to lose our cartilage. So there'll be a lot less cartilage in the tissue. And when we look at the function associated with the bronchi and bronchioles, it's the transport of air. Once again, that conditioning, so cleaning, warming, humidifying, that's all important. The cleansing activity of the cilia. And one thing that we do know that smoking does do, it actually damages the cilia. And one of the things you may know, some smokers in particular, they have a very distinctive cough. Okay? And here we can see a nice healthy airway, very nice cilia. Okay, it kind of looks like sea anemones. And here we're looking at the airway of a smoker. And look at how much damage has happened to the cilia. There's far less functional cilia here as opposed to that nice, healthy airway. Now, the lungs are those areas where gas exchange actually takes place. And some of the things that you need is a lot of surface area. One of the terms that you'll hear, the lungs have the surface area of a tennis court. Okay, so kind of imagine. Now, what we're going to find here is very well vascularized areas because once again, we need to be able to exchange gas, and that's going to be really necessary. The lungs, they're in the thoracic cavity, so there's a sub area, the pleural cavity, where the lungs actually sit, and the lungs are encased in a pleural membrane, and that's going to be important for ventilation. And the area between those two membranes, known as the pleural cavity, and it has a small amount of fluid, and what that's actually doing, it's reducing the friction as the lungs move during inhalation and exhalation. Now, when we look at the right lung actually has 3 lobes, whereas the left lung only has 2. And keep in mind what we're sharing space with in the thoracic cavity, and that would be the heart. And the heart is a little bit more closer to the left, okay? So that impacts the size of the left lung. Now, these lungs work relatively, for the most part, independent of each other. So that's important. Here we can actually see the pleural membrane. Okay? And so we can see those areas. There's that pleural cavity, and that's where the fluid's very, very thin. And then we have the part that's lining the thoracic cavity. Okay, so one part is directly on the surface of the lungs, and the other is attached, and that space in between is that pleural cavity with the fluid that reduces friction as we inhale and exhale. Now, the alveoli, this is actually where gas exchange takes place. So this is where we see the significant surface area. Now, when we look at the walls of the alveoli, it makes sense that this is going to be one of those areas where we actually see simple squamous epithelial tissue. So a single layer. Think about it. If we had multiple layers there, it would be a greater barrier to move through, and that more difficult to actually exchange gases. I kind of noted already the huge surface area. Okay, so about 800 square feet. I mean, think about it. That's a small home. All right, or an apartment. So kind of keep that in mind. Now, a substance that's actually produced by the alveolar cells known as surfactant. And what this does, it actually reduces surface tension, and it pretty much prevents collapse of the alveoli. Because keep in mind how microscopic our alveoli are. And so the walls are very, very close to each other. They're spherical shape. And the wall is actually lined with a very, very thin layer of fluid that's mostly water. Now, remember, water is a polar molecule, so water molecules attract each other. So you have this attractive force that's kind of opposing the inflation of the alveoli. So this surfactant actually decreases that surface tension and actually allows them to inflate. Now, quite often, when you have an infant that's born prematurely, they may not have enough surfactant, and this will result in respiratory distress syndrome in infants. Now, this can actually be treated by administering them surfactant. Now, this is also a very well vascularized area, and the pulmonary capillaries bring blood and air into very, very close contact so we can actually exchange. Now, remember, the lungs are receiving deoxygenated blood from the right ventricle of the heart through the pulmonary arteries. Now, the pulmonary capillaries, they actually allow the blood to come into very close proximity with the air in the alveoli. And then we're going to see venules and veins that collect the oxygenated blood from the alveolar capillaries. And now we go back to the left side of the heart, and that's going to be distributed throughout the systemic circulation. So here we get a really good feeling about the overall size. Okay, so quite often the alveoli are called like grape-like clusters. Okay, so a cluster of grapes. Quite often you can see how well vascularized they are. And once again, keep in mind the gas exchange. So here we've got blood coming from the right heart. Okay, then we're going to see the capillaries close to the vein, the alveoli, and then these are actually going to unload CO2. Okay, because we want to get rid of it, and then oxygen is going to move from the alveolus into the pulmonary on the arteries, and so we can kind of see that particular direction. Okay, so we've got the pulmonary arterial and then the pulmonary veins going on to the left side of the heart. Here we can see greatly magnified the alveolus. So keep in mind, okay, oxygen is going to move into the capillaries, and then we're going to unload CO2 into the alveolus, and we're going to eliminate that through exhalation. And here you can actually see the surface of the alveoli and all that red. Okay, lots and lots of capillaries here. Okay.